All right, for today, we have a very short and sweet lesson. We are looking at just how to simplify a square root today. This section covers simplifying, multiplying, and dividing, but just for today, today's video lesson is just the simplifying part. There are actually numerous ways you can kind of attack these problems. I'm going to show you what I have found to be the easiest way for students to understand how to do these. And I'm going to show that method to you, so whatever's the easiest. We will use this method all the way through the entire semester. So if you have questions, make sure you reach out to me and ask. All right, so here we go. Simplifying square roots. If b squared equals a, then b is the square root of a. So for example, if 3 squared equals 9, then the square root of 9 is 3, right? Square root is just what number times itself, or what number squared gives you that. So the symbol used to denote a square root is the radical sign, which I'm sure you've seen many times before. I don't use the word square root a whole lot. I usually say radical. So if you hear me say radical, I'm not like a, blonde-haired surfer dude, right? I am just saying radical as in the math symbol, not radical, groovy, gnarly, those kind of words. Anyway, all right, an expression containing a square root is simplified when all perfect square factors have been removed. You're going to learn really fast in this class that we do not use decimals. Everything needs to be exact. Decimals are rounded off. So we will leave things in radical form. So let me go through this example here, showing you how to simplify a square root, and then we'll try some of them together. Right? So we are going to create a factor tree to find all the factors of the number. So in this example, they had 24. The square root of 24 is not perfect. So if you do your factor tree, this one went 2 and 12. 12 is 2 times 6. 6 is 2 times 3. The highlighted parts, or the parts that I circled, are prime numbers. Those are the numbers that do not break down any further. You want to take it all the way down to primes, and then we are going to look for pairs. Okay, I have a pair of 2's, so these two 2's come outside as a single 2. That's one you've seen here. And then the leftovers, the 2 and 3, are inside, multiplying to give you the 6. Now, I like weird ways to remember things. So for me, the easiest way to remember this is I'm going on a date. So me and my couple, right, the couple, the two of us, that's the pair that I have here. When we go out to the restaurant together for dinner, we are one couple. So just one of us shows up out here. Now, the mathematical reasoning for that, 2 times 2, these 2's that I'm using, is 4. And the square root of 4 is 2. That's why it's coming out. But I like weird ways to remember things. Now, the other numbers, the leftovers, and I call them that on purpose, right? They're left over. They don't have a partner. They don't have a pair. They don't have a date to go out. Leftovers, where do you put your leftovers? Think about it. You go out to a restaurant. You don't eat all your food. You package up your leftovers, and when you get home, you put your leftovers in the fridge. So these leftovers go in the fridge, inside that radical. All right, so if we can remember leftovers in the fridge, we're golden. All right, let's just jump right in and let's try some. So the square root of 32, obviously first and foremost, if it's perfect, just tell me what it is, okay, right? If it was 36, square root of 36 is 6, you'd be done. Since it's not perfect, your calculator, if you try it, gives you a decimal. We are going to split and do our factor tree. So I'm going to go 2 and 16, 2 and 8, 2 and 4, and then that's 2 and 2. Right? Now, if you kind of split that in different ways, that's okay. It doesn't matter which way you split your multiplication. You will still end up with the same numbers circled, the same primes. So don't worry about that. All right, once you have it all the way down to primes, we look for pairs. And I always cross them off as I go. So there's a pair of 2's. They're out on a date, right? They're out together. It's just a 2. I have another pair of 2's. They also come out. And I have a leftover. Leftovers go in the fridge. Now, the 2 that are out here, I'm going to multiply those together. 2 times 2 is 4. And I have radical 2. Now, if you're somebody who's like, I don't know if I did that right or not, grab your calculator. If I type in the square root of 32, just so you can compare, it's about 5.6568, blah, 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 right? Those numbers are going to keep going on and on. Check my answer, 4, and then, oops, I hit some very wrong buttons on my calculator. So 4 times the square root of 2, and I get the exact same decimal expansion that I see up here. So if you're ever not sure if you did that right, you could always type it in your calculator, and it will tell you whether or not that they're the same. They're the same decimal expansion. All right, let's try number 2. Factor tree. So 2 and 27, that's 3 and 9, 3 and 3. Once you get all the way down to your prime numbers. And again, if I am moving too fast, basic math skills are my strong suit. If you're a little slower on that, that's okay. Just hit pause if I get going too fast on my factor trees for you. And we are looking for pairs, right? So I have a pair of 3s, so it comes out as 3. And that's the only pair I have. All right, leftovers, I have a leftover 3 and a leftover 2. 3 times 2 is 6. Leftovers in the fridge. All right, why don't you guys try number 3 on your own? So right now, go ahead and hit pause, try number 3, and then come back and let's see how we did. All right, so square root of 224, sorry, is not perfect. So let's do our factor tree. I'm going to go 2 and 112. I like 2s in case you didn't notice. That's going to split to 2 and 56, 2 and 28, 2 and 14, 2 and 7. All right, so once I get my pairs, or my factor tree all done, I'm going to look for pairs. So I have a pair of 2s, comes out as a 2. Another pair of 2s, comes out as a 2. Leftover 2 and 7, 2 times 7 is 14. Leftovers in the fridge. Cleaning this up a little bit, we get 4 times the square root of 14. And that is the simplified version of radical 224. All right, 3 more to go, and then we're done for the day. All right, so number 4, notice we have a number out in front, okay? The number in front is just like, you know, we're on a double date and we're meeting somebody at the restaurant. They're already out there. So for the time being, I'm actually just going to ignore them. I'm going to clean up my radical 48. So that's 2 and 24, 2 and 12, 2 and 6, 2 and 3. And I'm going to look for my pairs. I see a pair of 2s and another pair of 2s. I have a leftover 3, leftovers in the fridge. And don't forget, your friend who's meeting you at that restaurant is already there. So they're already outside. They're going to join up with me when I'm outside as well. So 3 times 2 is 6, times 2 is 12, and I have radical 3. All right, number 5. Oh, we have a negative number out front. That's okay. It's just a friend that's at the restaurant who's a very negative person. It's all right, they're still our friend. We're going to ignore him while we clean this up. So radical 108, I'm going to break that down to 2 and 54, 2 and 27, 3 and 9, 3 and 3. All right, once I've broken it all the way down as far as I can, I look for my pairs. I see a pair of 2s. I see a pair of 3s. I see a leftover 3, leftovers in the fridge. My friend out here who's already at the restaurant waiting for me, I'll bring him down. And now I can just clean this up. Negative 5 times 2 is negative 10, times 3 is negative 30, and I have radical 3. All right, once again, it is your turn. Number 6, go ahead and hit pause, try number 6, and then come back and let's see how we did. All right, number 6. Again, I'm gonna do my factor tree. I'm gonna go 2 and 300, 2 and 150, 10 and 15. Again, if you went a different route than me, totally fine. 2 and 5, 3 and 5. Okay, so if you did it different than me, it's actually a great chance for you to see that we should end up the same answer as long as your basic math was good. All right, looking for pairs, I see a pair of 2s. I see a pair of 5s. a leftover 2 and a leftover 3. 2 times 3 is 6. Leftovers in the fridge. My friend that's already at the restaurant waiting for me. And then we'll clean it up. -4 times 2 is -8 times 5 is -40. And I have radical 6. All right, nice job, guys. All right, one last problem, bonus problem for you. So go ahead and just add this to your notes if you would. Just because it comes up every year and I want to make sure we're okay. So square root 144. Now, what you're going to notice is a lot of people right now, you're probably already thinking it. What's the answer? It's 12, right? Square root of 144 is perfect. It's 12. If you are someone who does not recognize them, okay? Obviously, if you do, I'm going to write down it's 12. I'm moving on. I'm going to the next problem. But if you did not recognize that and you jumped right into your factor tree, I want you to see what happens, right? So that's 12 and 12, 2 and 6, 2 and 3, 2 and 6, 2 and 3. Obviously, make sure you are circling your prime numbers to make sure that you don't accidentally reuse numbers you shouldn't, and cross them off as you go. I see a pair of 2s. I see another pair of 2s, and a pair of 3s, and I don't have any leftovers. I don't have any leftovers because it's perfect, okay? So if you recognize that, it's perfect, go ahead and just write the answer down. But if you don't panic. If you get down to your factor tree and you're like, I don't have any leftovers, that's a red flag to you that that meant that was perfect to begin with. So 2 times 2 times 3 is 12. So whether you noticed it was perfect or not from the beginning, it's kind of irrelevant because you can still get there even if you didn't notice it. All right, we will be doing factor trees, simplifying radicals all semester long. So if you have questions, please reach out, let me know, and I'll be happy to sit down with you and help you work through it.